Hello, welcome. Today we are going to look at another form of enthalpy known as enthalpy change of combustion. Last time we had a look at enthalpy change of formation, but this time we want to see what happens when you burn a given substance in air. Usually combustion talks about burning in air. However, we know that the main active component of air is actually oxygen. So our combustion will mainly be restricted to burning of these substances in oxygen. So enthalpy change that occurs when 1 mole of a substance is completely burnt in oxygen under standard conditions of temperature and pressure is our enthalpy change of combustion. Take note, we are talking about 1 mole of a substance, and then we are burning it completely in oxygen under STP. So let's look at some scenarios and see what we exactly mean by 1 mole of a substance completely burnt in oxygen and so on. Let's look at enthalpy of combustion of carbon. At least this is one of the most common enthalpy changes of combustion. So we have the equation, we have our carbon reacting with oxygen to form carbon dioxide. As you can see, the equation is balanced. However, we have 1 mole of carbon here, and it is completely burning in oxygen. That's why we are forming carbon dioxide and not carbon monoxide. So that means we are completely burning our carbon in oxygen. So if such a reaction takes place and we realize that the amount of energy that is released is minus 393 kilojoules per mole, this becomes the enthalpy change of combustion of carbon. So basically enthalpy change standard of combustion of our carbon. So enthalpy change of combustion of carbon becomes minus 393 kilojoules per mole because we have burnt 1 mole of carbon in excess oxygen or completely burnt it in oxygen to produce our carbon dioxide. The second example, we can try to look for enthalpy change of combustion of our methane. So when you look at methane, CH4, if we burn it in excess oxygen or completely in oxygen, we shall also produce carbon dioxide and water. In this case, we are not producing carbon monoxide. Otherwise, we shall not be burning it completely. So all we have to ensure that we have 1 mole here, and then we balance our equation with the 2 and the 2. So the amount of energy that will be released, in this case it is unknown as X. So this minus X kilojoules per mole will be the enthalpy change of combustion of 1 mole of methane. Then lastly, one common example is the one for glucose. What is the enthalpy change that we might get when we burn 1 mole of glucose? Glucose is C2H5OH in oxygen to form carbon dioxide and water. So all we have to do here is to ensure that we balance this equation. We have 2 atoms of carbon this side, so we shall put here 2. So carbon is balanced. Hydrogen we have 6, 5 plus 1. This side we have 2. We can multiply water by 3 so that we get 6 hydrogen atoms. So we shall be left with 4 oxygen atoms plus 3, which is 7. This side we have 2 plus 1. So if we make this one 6 plus this one, it will be 7. So this is a balanced equation. However, we have 1 mole of ethanol. So when we burn 1 mole of ethanol in our excess oxygen or completely burning it in oxygen, we shall form our carbon dioxide and water, just like the equation before. So the enthalpy change of combustion of our ethanol will become minus 1367 kilojoules per mole. So whenever we talk of standard enthalpy change, obviously we are talking about STP, standard conditions of temperature and pressure. But if we just say maybe enthalpy change of combustion, then we are basically meaning the enthalpy change that occurs when 1 mole of a substance completely burns in oxygen. So standard brings in the aspect of STP. However, the keywords are 1 mole of a substance and completely burnt in oxygen. Thanks for watching. If you find these videos useful to you, don't forget to like, share and subscribe. Stay safe.